All right, let's dive into the incredible and kind of secret origin story of a muscle you're using right now, this very second, but probably never think about your diaphragm. Turns out, its construction is an absolute architectural marvel that happens long before we're ever born.
So, think about it. What's the one muscle that powers your body from your very first breath to your very last? It's the unsung hero behind every laugh, every sigh, every song you belt out in the car. Of course, it's the diaphragm. And honestly, the story of how it gets built is one of the most amazing journeys in all of human development. So, before we jump in our developmental time machine, let's just take a second to appreciate the finished product. This is our unsung hero, the powerful, elegant muscle that's working tirelessly inside all of us right now. But here's the thing, it does way more than just help you breathe. The diaphragm is a critical physical barrier. It's this dome-shaped wall that separates your chest cavity, where your heart and lungs live, from your abdominal cavity down below, which is home to your stomach, liver, and all that. It's basically the bouncer that keeps all your organs in their VIP sections. Now, to really understand how this crucial wall was built, we have to go way back. Back to when you were an embryo, just a few weeks old. And at that early stage, the internal layout was, well, let's just call it an open floor plan.
I mean, look at this. At around 24 days, there is no separation. At all. The future chest and abdomen are just one big, continuous space. This open floor plan is totally normal for this stage, but it's a huge design problem that the embryo has to solve, and fast. So, the first step in the construction project is laying the foundation. This structure here is called the septum transversum. Think of it like a thick plate of tissue that starts growing from the front, forming an incomplete shelf between the future chest and abdomen. But this foundation isn't perfect, not by a long shot. It creates a major architectural problem. See those two huge gaps on either side? They're called the pericardio-peritoneal canals, and they're basically wide-open doorways between the chest and the abdomen. If those aren't sealed up, organs could end up in the wrong place, and that would be catastrophic. So how does a tiny little embryo solve this massive architectural challenge? The solution is both really elegant and, frankly, ingenious. It's time to build the rest of this crucial wall.
The way it happens is almost theatrical. Seriously, it's like a pair of curtains being drawn across a stage to close the show.
Okay, so picture this. It's around the 5th week of development. Suddenly, these two crescent-shaped folds of tissue start to emerge from the body wall. These are the curtains, and they're called the pleuroperitoneal folds. Their job is to close those gaps. And they are on a mission. They don't just sit there. For the next couple of weeks, these folds are actively growing, stretching inward and forward, what we call medially, on a direct collision course with that foundation, the septum transversum. And then, by the 7th week, it happens, the moment of connection. The growing folds meet the septum transversum, and they fuse together. Boom! The canals are sealed shut, and for the very first time, the chest and abdominal cavities are completely separate. The Great Wall is complete. Okay, so the wall is built. Problem solved, right? Well, not quite. A wall made of a simple membrane just isn't strong enough to be the body's main breathing muscle. It needs power. It needs muscle. It's time for the final assembly. And this is where the story gets really, really wild. The muscle cells, these things called myoblasts that are going to power the diaphragm, they don't come from anywhere nearby. No, they undertake this epic migration all the way down from the neck, specifically from cervical segments 3, 4, and 5. They travel all that way and then invade these newly formed membranes, transforming them into the powerful muscle we know. And by the way, that crazy long journey is exactly why the nerve that controls your diaphragm, the phrenic nerve, also starts way up in your neck. So these migrating muscle cells, they fill in the outer parts of the diaphragm. But the central region, right where everything fused together, that part stays non-muscular. It develops into a super strong fibrous sheet called the central tendon, and it acts as the perfect anchor point for the muscle to pull against. I mean, this whole process is a delicate and perfectly timed biological ballet, isn't it? But what happens when one of the dancers misses a cue? What happens when those curtains don't quite close all the way? And that's not just a what if. A failure in this process happens in about 1 in every 2,000 births, and it leads to a really serious condition. That condition is called congenital diaphragmatic hernia, or CDH for short,
It's a birth defect where a hole literally remains in the diaphragm, which allows those abdominal organs, like the stomach or the intestines, to push their way up into the chest cavity.
This whole thing happens simply because those curtains, the pleuroperitoneal folds, fail to fuse correctly. And what's really interesting is that this happens on the left side about 85% of the time, maybe because the right side tends to close up a little earlier. Now, when abdominal organs squeeze through this hole, they crowd the chest, and they leave absolutely no room for the lungs to grow properly. And that is the most dangerous consequence of CDH.
So why? Why does this fusion sometimes fail? Well, research points to a problem at the cellular level. There's this quote, which basically means that the cells responsible for building the framework, the scaffolding for the new tissue, they're called fibroblasts. They just fail to provide the right structure. Without that scaffolding to guide them, the migrating muscle cells get lost, and the membranes just can't fuse. It's a tiny microscopic error with absolutely devastating consequences.
The foundation, the closing curtains, that incredible migration of cells, all of it happens perfectly in most of us in just a few short weeks. It's a pretty stunning reminder of the silent, incredible architectural feats that build us long before we ever take our first breath. It really makes you wonder, what other secrets are hidden in our own blueprint?